So here we've been given the length measurements, so we want to try to keep all the ratio parts in exact values because the ratios go with the lengths of the sides. And given the lengths of the sides, we can keep everything in exact values. Only when we need to use our calculator to go from the ratio to the angle, or sides to angle, that we need to use our calculator, and thus we're going to introduce decimal values when we do that. So here we know that x is equal to 3, y is equal to 4 based on that coordinate. To calculate the radius, we use Pythagoras, so 3 squared plus 4 squared is going to give us 25, so the radius is going to be the square root of 25, which is 5. Once I have the three sides, I can write down the ratio of the angles. The cosine ratio is going to be, cosine, remember, goes with horizontal. Cosine is going to, maybe I'm going to color code this here. So cosine is going to go with x. I think we did green for that. Let's see here. So x is equal to 3. So we have a cosine ratio of 3 over 5. Okay, the sine ratio is going to be based on our y coordinate of 4. So we end up with 4 over 5 as our sine ratio. And then the tan ratio is going to be the vertical rise over run. Okay, so there's our tan ratio. So all that is in exact values. We keep that in exact values. And to convert to the angle now, this is where we need to use our calculators. Now I have all three ratios, so I could use any one. So I'm just going to use the top one. I'm going to convert that into this inverse function before I apply the inverse function. So this is where you may not have, this might be different from what you did before, but now this is what we really want to work on, is expressing the inverse algebraically. So it's going to be the input is going to be the ratio, the output is going to be the angle theta, okay, and then I'm going to plug it into my calculator. So I'm going to do 3 over 5, and the inverse cosine gives me 53.13 degrees. Okay, so there's my angle, and the angle based on those, this is not quite proportionally correct, but based on those proportions is about the right angle. So here again we've been given the opposite. So here we're given the position. Here we're given the angle. So we're going to have to somehow at some point use our calculator, and then we're going to need that to express x and y positions. So the 23 degrees then allows us, with our calculator, allows us to convert to ratio or length components. So we want to solve for x and y. So we need to set up some ratio for this. So x is my horizontal. Okay, so x is horizontal. So I want to connect horizontal with cos. So I'm going to set up my cosine ratio. So cosine of theta, so not theta, but 23 degrees is equal to x over 19. Okay, I can solve for x by working out my cosine ratio, but I need my calculator to do that. Okay, so if I want to find out the cosine of 23 degrees, I'm going to do 23 cosine is going to give me 0.921 is equal to x over 19. I can solve for x by multiplying that by 19. So I end up with the x length is 17.4, we'll round that to 49. Okay, so that's going to be 17.49, and that's about right given 23 degrees. For the y, I'm going to need my sine ratio. So So y, I want you to connect the vertical with sine. So sine of 23 degrees is y over 19. Okay, so sine goes with the vertical or sine goes with y. So I'm going to take my 23 degrees and find my sine ratio. So at this point I need to convert that to a ratio, so I need my calculator. This is where I introduce my decimal values. 0.391 is equal to y over 19. Solving for y, I multiply that by 19, and I end up with 7.42. Okay, so y equals 7.42, and looking at the proportions, that looks about right, what I would expect for 23 degrees. Okay, so there's my values, x and y, and so the x and y coordinate then, as a coordinate pair, are listed as 17.49 along the x, 7.42 along the y, and that coordinate defines this point on the circle, which also is defined by that angle. So that position is what we're looking for.